Hello everyone. Today we are going to be learning the basic fundamentals and principles of counting. The subtopics that we are going to be covering is the pigeonhole principle, binomial theorem, and probability.
Firstly, the pigeonhole principle. Pigeonhole principle states that if you distribute n items into k containers, where n is greater than k, and at least one container must hold more than one item. So for example, you have 4 empty boxes and 4 toy ducks. And now in order to satisfy the condition that n is greater than k, we add 1 in n, which makes n is equals to k plus 1, which it equals to 5. And so if we were to put all the ducks in the boxes, at least one of the boxes will have more than one ducks. And that is the pigeonhole principle. So this is also a powerful principle in computer science to detect data collisions or in mathematics to prove existence statements.
Next, let's talk about the binomial theorem. This theorem provides a formula for expanding expressions of the form of a plus b powered by n. The binomial theorem is expressed as such and can be divided into two parts, the coefficient and power. Let's see an example. If we want to expand a plus b powered by 3 using the theorem, we can chuck in the values accordingly. We repeat this until the n term, and in this case 3. And when we simplify this, we will get the answer a cubed plus 3a squared b plus 3ab squared plus b cubed. This theorem is useful in combinatorics, probability, and algebra. For instance, calculating probabilities involving multiple independent events.
And finally, let's dive into probability. Probability is the measure of the likelihood of an event occurring and base formula that takes the conditional probability formula and reverse it. As we know, the conditional probability formula is as such, with the probability of A given B is equals to the probability of A and B over the probability of B. Let's now write another expression with this formula. Probability of B given A is equals to probability of B and A over the probability of A. Now we can see that the probability of A and B is the same as the probability of B and A. And we can write it like this. And that the probability of A and B is just the product of probability of B times probability of A given B. And same as the other side. And once we divide both sides with probability of B, we will get this new formula, and this new formula becomes the Bayes theorem. Now let's take a look at an example using these formulas. Now we can see the Venn diagram here. A is equals to 36 plus 7 equals to 43. B is equals to 7 plus 13 and equals to 20. And the sample size is 36 plus 7 plus 13 and plus 14, which totals up to 70. And we can see the intersection here of A and B is 7. Now, what is the probability that someone likes ice cream given they like donuts? Well, we can use the conditional probability formula. Now we know that the probability of A and B is just equals to 7 over the sample size, which is equals to 1 over 10. And the probability of B is 20 over 70, which equals to 2 over 7. Now using these two values, we can just plug it into the formula and we get the answer 0.35 or 35%. Now when do we use the Bayes theorem? Well, let's check out another problem. A particular study showed that 12% of men will likely develop prostate cancer at some point in their lives. A man with prostate cancer has a 95% chance of positive test result from medical screening exam. A man without prostate cancer has a 6% chance of getting a false positive test result. What is the probability that a man has cancer given that he has a positive test result? Let's first lay out the information given. The probability of a man getting cancer is 12%, which is 0.12 in decimals, and the probability of a man getting a positive test result given that he has cancer is equals to 95%, which is 0.95. And the probability of a man without prostate cancer and getting a false positive test result is 6%, which is 0.06. Now, what we're looking for is the probability of a man having cancer and given that he has a positive test result. So let's use the Bayes theorem, which is probability of a man having cancer given that he has a positive test result is equals to probability of positive test result given he has cancer times probability that a man having cancer over the probability of a positive test result. Now we can see that we have these two values, the probability of a positive test result given the man has cancer and the probability of a man having cancer. But we do not have the probability of a positive test result. Now to find this value, it's best that we use a tree graph, which is the possibility that a man having cancer is 0.12. So the probability of a man not having cancer is just 1 minus 0.12, which is 0.88. And the probability of a man having cancer getting a positive test result is 0.95, with the latter being 0.05. And same goes with the probability of a man without cancer and getting a positive test result is 0.06, and the negative test result is 0.94. Now to get the probability of the positive test result, there are two ways, which is the probability of a man having cancer and a positive test result, or the probability of a man not having cancer and a positive test result. With this, we know that the probability of a man having cancer and positive test result is just 0.12 times 0.95 plus the probability of a man not having cancer and a positive test result, which is 0.88 times 0.06, which we get 0.1668. Now with this value, we can now plug it in into the formula again with the probability of a man having cancer given he has a positive test result is equals to 0.95 times 0.12 over 0.1668. And the answer is 0.683 or 68.3%. And that is how you use both the conditional probability formula and the Bayes theorem. Probability is used everywhere, from predicting the weather, assessing risk in finance and insurance, and even in game design. By understanding probability, we can make better decisions in uncertain situations. Thank you for watching the video, and I hope that you've learned something new today. The slide used in this video is down in the description below, so be sure to check it out. Again, thank you for watching. See you next time.